this is the third episode of our AI and machine learning tutorial. Let's start.
So now, if we try to understand generative AI and its impact, to understand that, we have to understand the 2017 paper which came, which is "Attention is All You Need" by Mr. Vaswani and team. Uh, though earlier we have seen ENN, CNN, RNN, LSTM, GAN, and other models, the self-attention paper, this paper, "Attention is All You Need," where the transformer architecture came. I think that changed the game, if I say. So transformers, they introduced the transformer architecture, which is again the deep learning model used to understand and generate human-like text. They use something like attention to focus on important word in the system, and they were actually built for NLP tasks like translation, summation, and question answers. So they were introduced by Google in 2017, where the paper "Attention is All You Need." Attention is all you need paper. Now, this was a very important paper, which we said in 2017 it came, and it does mainly three things, which are the apart from many other beautiful things which it highlighted. One was that it removed the RNN, LSTM, all those architecture with the fully attention-based transformer architecture, which simplified the thing, and as well as for the sequential things, it actually made the things really clean and faster with the self-attention mechanism. So transformer architecture is sort of, you can say, it's a big breakthrough, which was presented in this paper. Second was the parallel training. So before that, maybe in the RNN and LSTM, though it was possible to translate the language, or we'll take that example. So let's say if somebody is saying the sky is blue, so the encoder decoder model, what used to happen is that you take the full sentence, the sky is blue, all four words you encode it and then pass to the decoder. As you can imagine, if passages or lines are long, it becomes very cumbersome to pass and do those things. Instead, what this paper proposed was, with the help of transformer architecture, we will do the things in parallel. Means each word can go to the decoder in a parallel way, but uh, because now all words are going parallelly, and in the language, sequence is very much important. So this is where the third thing came, which is the position encoding. So you still determine where in the original sentence the first word was there, so that even if jumbling happens in the decoder side, you can always, with the help of position encoding, figure it out, which again, in the, let's say, in the translated language, where each word should fall in. So three things. One is the transformer architecture with the self-attention model. So you determine which word is most important in that sentence, and similarly the parallel training. So that make the thing faster, and the positional encoding, which so though the parallel training was happening, but position was somehow maintained in that architecture. So that is where it's very important paper. The "Attention is All You Need" is called. Self-attention mechanism came, which learned context better, and it's like it gave rise to the powerful model like BERT GPT handle long text, because though the earlier models, especially RNN or LSTM, started were doing language translation, but they were able to do for up to certain length, up to some passages. But if there are long passages, or a book or things like that, so they used to forget from where they started, and that is where the transformer model helps. And one of the other advantage was that by this now you could have pre-trained the model, and then that pre-trained model can be reused for certain other thing. Now this gave a boom because now when you bring down the cost, or the speed has gone up, parallelization has happened, and you have pre-trained model, which, let's say, if you're in the domain of banking, which knows general banking, now you can take that model and contextualize for your task and fine tune your. You don't have to start from scratch. So this is one of the big power of transfer learning, which came along with the transformer thing. Some of the real world example you can think of it: the ChatGPT, Google Bard, Claude, which use the transformer. If course has a big impact on the deep learning, because the earlier architecture which was used, the transformer replaced all those architecture, and of course it expanded, and like, let's say, combining with the vision, that vision transformer came, which again applied the same concept of transformer, which was getting used in the text to the pictures and various images. The again the self-attention model to identify the uh, image and classify. So though the CNN architecture was doing on the neural network, the vision transformer brought the attention mechanism in the image processing, which that way it was able to do maintain at the global level the attention, and the big images, or a large amount of images can be classified or can be generated, and of course that brings a lot of efficiency at scale in these AI models. Use the transformer architecture. BART is from the Google is there, and GPT by OpenAI, which powers the content generation. So, what it has done, so transformer replaced the older architecture and expanded into, even in the computer vision, efficiency in scale has happened, made large scale AI model and cross domain, which what it means, like, after this transformer model, which was for the text, then vision transformer came, which again utilize on the what is happening on the image processing. So leading generative AI model, if we try to review it, like a GPT-4, BERT, DALL-E, Midjourney, Stable Diffusion, Musical.M by Google, uh, and then Hugging Face, OpenAI, TensorFlow, and PyTorch, Stable Diffusion. Uh, OpenAI, of course, the GPT model, which everybody sort of downloaded, started seeing Google DeepMind, and we are seeing the continuous innovation from these companies. Anthropic's Claude AI is there, Meta large language model is there, and Microsoft AI, which we see the Copilot in Office 365. So these are the leading innovator, I will say. Gen AI in the cloud, this one is Google Vertex AI, Azure Services, Amazon Bedrock, and AI model deployment examples are there. Generative AI models, if you see, like GPT-4, again, large scale large language model, DALL-E is there for the image creation, stable diffusion, again, open source text to image model, allowing custom fine tuning. Claude is there, which is which emphasizes a lot more on the ethical data, and even the passages it generate or the content it produce. You can say it's a notch higher than the other models. Uh, and of course, it gets used in the customer support automation. Uh, Biases part is lesser in the cloud that way. Gemini is like multi-modal and coming from the Google, Google ecosystem, which has so many things: the text, image, audio inputs, and then music gen is there for the music generation and many other things. And the libraries, you will see the Hugging Face, Diffusion, LangChain, TensorFlow, Deep Speed, which is the generative AI main libraries are there. OpenAI API is there. Then the T5X is there, and GPT Index, Kira, CV, Alpha, LoRa is there. So these are the main things of the generative AI is there. Uh,
Hopefully, you must have got an idea of how AI, ML, deep learning, Gen AI fits in this overall AI ecosystem. Uh, Watch for this series because I'm going to make videos deep into all these subjects. So, if you like this video, please share it, subscribe it, and subscribe my channel. Thank you.